Good morning, friends. This is Sachin Fiske from Electrical Engineering Department. Today we are going to start the implementation of a VFD along with the PLC system. In the previous lecture, we discussed about general or introductory part of the variable frequency drive system. So as all of you know that general induction motor, how this induction motor will run, just a simple 3-point starter can be used and your induction motor will be run. And there are so many techniques available to control the speed of the induction motor. Here, 3-phase supply is given to SFU. What is SFU? SFU means switch fuse unit. So 3-phase supply is given to HRC fuses. The output of this HRC fuses will be given to contactor. Again, the output of this contactor will be given to the relay system, and this whole combination is known as switch fuse unit. Now this output of this SFU will be given to the rectifier cum PWM inverter. Why this rectifier and why this PWM inverter? As we are going to implement PLC to control the speed of the induction motor, and hence we are going to use the rectifier. Our PLC system will be operated on plus minus 5 volt DC supply, and that is why we require to change the input AC supply into rectified DC supply. Again, our induction motor actually needs 3-phase AC supply or simply AC supply, and that's why here again one PWM inverter can be used. So complete combination combines, that is rectifier cum PWM inverter, means it is work as a variable frequency drive. So what is the exact function of this variable frequency drive? To control the V by F ratio constant, and as the V by F ratio will constant, at the same time our aim can be success. Now in the opposite direction, if we see this computer operator, that is power control room of the, or simply to control the induction motor speed, any of the computer operator will be there. So by using the programming, simply this PLC will give the programming languages to this induction motor, and it is a bidirectional. So PLC can accept or execute the data which is given by the computer operator. At the same time, we can change the speed of the induction motor, or we can increase the induction motor. Now the basic fundamental of this variable frequency drive is that consider 230 volt supply, and secondly our frequency is 50 Hz. So if we divide this 230 volt into 10 parts and frequency into 10 parts, that is one part of the voltage is equals to 23 volt and one part of the frequency is equals to 5 Hz. So 23 by 5, this is the first ratio. Now second ratio will be 46 by 10. So if 46 by 10 we consider, it is again same as 23 by 5. In this way, this ratio will be kept as a constant. In this way, this ratio will be maintained, and by using this PLC along with VFD, the system will be implemented. So in this way, our system will operate.